Hello everyone. Hi, good evening. So welcome to PyNet Labs. So this is your webinar on QoS fundamentals for enterprise code. And in this webinar today, we are going to discuss like a lot more things about your quality of service fundamentals. And apart from that, we are also going to look more in detail towards the lab sessions. But before starting the webinar, I would like to let you all know that while starting the webinar, like when we will be doing the introduction. So you must be having some sound knowledge of OSI model, because as per the OSI model, we are going to cover the most of the part related to webinar. So let's get started without wasting any minutes. So the topic which we are going to start is, let's say we will be starting with your introduction to quality of service, which is also known as QoS. So this topic is basically, it's a part of your CCNA program also. And like when you will see, it's also a part of your CCNP and core trainings. So like we are going to cover some basics from CCNP and core also, but like we will give you some brief idea about like what we cover in the CCNA trainings about quality of service and why it is like, how it is being used in the production environments and what is basically the use of this QoS. So let's get started like with the quality of service. So we can say like quality of service, like if anybody is going to ask you what is quality of service, so we can say quality of service, or you can say QoS.
If you enjoyed the content of the video, don't forget to like and share the video and subscribe to our channel.
Is a method of giving priority to some specific information. Like what kind of specific information it can be? Like for example, we can take a simple scenario that normally we have, different types of traffic. Like for example, if you are working in a production environment, you could be having some like VoIP traffic, voice over IP. Let's say your company is using Microsoft Teams. So like, some video conferencing apps we can say. So this is one kind of traffic. Let's say if there is any FTP server in your production environment, users are browsing HTTP service, or ICMP traffic can be there. So there can be, different types of like traffic inside our organizations whenever we are looking as per the enterprise needs. So let's say that in your organization where we have connected some IP phones. So there are also some application used in the networks, like, which are going to use or utilize your lot of bandwidth, we can say. Like if you are talking about Microsoft Teams, so like Microsoft Teams is going to use some UDP protocol. So we know that it is going to take like or reserve a lot of bandwidth for specific this video conferencing app, right? So like there can be various data which is moving inside your network, like HTTP traffic, FTP traffic, or like various databases which can be inside your networks. So now whenever the data goes over the network, there is a possibility that whenever you are sending the data over the router. So for example, you have one router here. This is your router one, and this is your router two. So you have connected both of the routers. Let's say you have some like FTP server configured here, and users are also browsing some HTTP servers. So let's say the data will travel via this link, right? So there is like, there is some, let's say FTP traffic, and there are some users who are downloading something over the FTP traffic. So FTP traffic is almost eating up your entire bandwidth between the routers. So maybe like just because of that, your voice traffic is not clear, because voice kind of traffic like VoIP traffic is pretty much sensitive. So in that case, like packets may be dropped if you are using multiple services. So in these kind of scenarios, we have some kind of things like which can we can say like these things are going to minimize your bandwidth in that case, right? So we can say that how exactly the bandwidth will be minimized and how all these things will be manipulated. So what we can do is like we can configure something like to give a priority to a specific traffic, like saying that if a traffic is coming from voice or video, that should be sent first, and it has to stop all the remaining traffic. Or maybe we can define that voice traffic should be like guaranteed between some, like for voice traffic we can guarantee some reservation of bandwidth, like some 64 kbps up to like particular links depending upon what kind of links we are using. So if I define the quality of service, so we can say QoS is a method of giving priority to specific traffic over the network as it's moving over the traffic over the network or whatever the traffic which is moving over the network, and we can define this kind of traffic in different categories, and we can reserve some amount of bandwidth for specific traffic. Right now we have the another part which is your QoS terminologies. Now, what are this quality of service terminologies, guys? This is pretty much very important part for your quality of service, because we are going to see more in detail about all these things. So, like if we are talking about the quality of service, so we can also say like these are the needs of your quality of service, we can say. So let's say we have some latency. So what is latency? If I will define the latency, so it is something we can say it is the time, it is the time, it is the time we can say it takes for packets to travel across a network. Now, what is the specific, amount of time which is like your packets are going to take like while traveling across the network? So that is what considered as your latency. So over the network, specifically from source to destination. So like there are some allowed latency values as well. Like just let me write the allowed values, because these values can be asked in your interview purposes and many things like that. So you can also make sure you remember this point, that all these latency values, like if we are talking about the real-time communication protocols, there are real-time and non-real-time communication. So we can say real-time communication protocols, and another side we do have let's say non-real-time communication protocol. So it's non-real-time communication protocol. So like this real-time protocols are having some like 200 milliseconds. And here we do have some 400 milliseconds. So these are some, like we can say the allowed latency values. Now coming to the next QoS terminology, which is considered as your jitter. Now, when we are talking about this jitter part, guys, so jitter is nothing but we can say it is the difference in the latency, the difference in the latency between packets in a single flow. So this is what known as your jitter, or we can say, for example, we will try to understand this with an example. So let's say if one packet is going to take 50 milliseconds to travel across a network from specific source to destination, and it can be any specific source to destination, so that the following packet is going to take like, around 70 milliseconds. So the jitter is like here we have the 20 milliseconds of jitter. So jitter is experienced due to the we can say queuing or delaying experienced by packets during the network congestions. Or we can say like to prevent the jitter from high priority real-time traffic, that it is recommended to use queue mechanisms such as low latency queuing, which is also considered as LLQ, because that allow the matching packets to be forwarded prior to any other low priority traffic during the periods of network congestion, we can say. So this is why like that jitter is also there like in the QoS terminologies whenever we are discussing all these terminologies. So now coming back to the next point, we have packet loss. The third one we have is your packet loss. Now, whenever we are talking about this packet loss part, guys, like here in this packet loss, we can say that packet loss is usually a result of congestion over a interface, specifically we can say. So we can just let me write down here like packet loss is usually a result of congestion on a specific interface, because can be seen on only interface. So like there are possible we can say approaches to prevent this kind of scenarios, that we cannot face any kind of packet loss inside our like network or over the interface, we can say. So just let's try to understand the categories, like what are the following approaches. So let's let me write down here. We can write packet loss can be prevented by implementing these approaches, prevented by implementing these approaches. Now, what are these approaches? So we'll try to discuss the approaches as well. Now, guys, see the first approach is we can increase the link speed. So increasing the link speed will like, it will maintain that there will be no packet loss. So increasing link speed, we can say, is one of the factor. The another one we do have is your implement QoS congestion avoidance, implement quality of service congestion avoidance. So once you have avoided congestion on the QoS and there are some QoS management mechanisms as well, which can be implemented here. Or you can say like one more factor is there, like one more approach we can say, implement traffic policing. This can also ensure that there will be no packet loss. So implementing traffic shaping, guys, to delay the packets instead of dropping them, since the traffic may burst and exceed into the capacity of interface buffer. So like make sure and always remember this point that whenever the traffic is not recommended, like traffic shaping is like never recommended for the real-time traffic. So it relies on the queuing that can cause jitters. So this is one of the factor that we are like traffic shaping is not recommended for the real-time traffic. Now coming to the need of quality of service, like why do we need this quality of service? So need of QoS we have. So if we are talking about the need of quality of service, so first thing we can say is like lack of bandwidth. So we can utilize this part here, lack of bandwidth. Lack of bandwidth is not permanent, it is on temporary basis, we can say. Then again, we have the next factor, which is latency. Latency, like we can say delay, and we can say jitter, which is variable delay. So these are two more factors. And what is like other need for quality of service, which is your packet loss. So that is like one of the these are some of the needs of quality of service. Like why do we need these quality of service inside our production environments, and why basically it is being used. Now guys, see, like when we are implementing the quality of service, there are some descriptive models, and accordingly like we will see how it is going to differentiate between what kind of model it is being used and like where it is gonna be used. So we'll try to see like when we will do the classification, but let's try to understand there are some quality of service models as well. Like there are two types of models, we can say QoS models. So the first one we have is your integrated services. Now these integrated services are also known as INT serve, int serve. So you will also see this type of term like int serve, and they are going to use some RSVP. I will explain you what is this RSVP later on when we will discuss the quality of service model, guys. Now coming to the part like what is this quality of service model, like which is integrated services here, which we are talking. So we can say that here it is something like when we are talking about the integrated services. So it is something like application signals, we can say, like any application signals, signal the network to make a bandwidth reservation and to indicate that, and to indicate that they require special QoS treatment, indicate that they require special QoS treatment. Now, what does I mean by this statement? That application signals the network to make a bandwidth reservation and also to indicate that they may require special QoS treatments. So like these models, like in service models are basically, we can say these are based on like flows. So we can say this model in service model is based on flows. Like what kind of flows I'm talking here? Like that can be your, let's say, source and destination IP. Source destination IP can be there a factor. And apart from that, we have some port address also. So that could be a part of this like model here. So this is like this model is based on the flows, we can say, and it also uses RSVP. So RSVP is a protocol here. I'll explain you later. RSVP is used here for end-to-end resource reservation. Is used here for end-to-end reservation. So guys, see, like this end service model was created for like, we can say for the real-time applications such as voice and video that require bandwidth, delay and packet loss guarantees. So in this model, like if application signals their requirement to the network to reserve end-to-end resources, like such as bandwidth, we can say like some reservation we want to do. So they require to provide an acceptable user experience. But end service users, like, it uses this RSVP. This RSVP stands for Resource Reservation Protocol. Just let me write the full form. RSVP stands for Resource Reservation Protocol. So this INT model is going to use this RSVP to reserve the resources through the network for specific applications. So we can say, here I will write with another pen so you can also take the notes, that RSVP to reserve resources throughout a network for specific application, throughout a network for specific application. And that application can be any specific application, we can say, like, to provide some, let's say, CAC, which is call admission and control, to guarantee that no other IP traffic can use that reserve bandwidth. We can say that also. So, like, to be able to provide end-to-end quality of service to all the nodes, or including the endpoints, like running the applications, need the support, build, maintain the RSVP path in every single flow. So, like, the bandwidth is reserved by the application, that is being not being wasted. But here we do have a very biggest drawback of using this model, which is known as your end service. So, like, I can say the biggest drawback of end service, because it cannot scale on very large network that might have thousands of millions of flows due to large number of RSVP flows. So that would not be maintained in that case. So, like, we do have some advantages, and as well as we can say some disadvantages. So we can say it's good for managing the flows in the small network. So this is one of the advantage we can say. So just let me write here. End serve model advantages versus we'll discuss some disadvantages, like what are the advantages and what would be the disadvantages. So we can say that we have, like, it's a good solution for managing flows. A good solution for managing the flows. Now, what kind of flows? Like, which we have already discussed, that it is going to use RSVP protocol for the flows, but inside only small networks. It's not scalable for large networks. So it's only scalable for small networks because it is having the poor scalability. So this is one of the disadvantage here, we can say, and it's pretty much difficult in implementation also. So this is what your first model of your QoS is, which is stands for end service, or like we can say integrated services. And you can also get these terms like INT serve. What is INT serve? So we can say that this is basically a part of your QoS models. Now coming to the next model, we have differentiated services. What is the meaning of differentiated services here? So we are going to see the differentiated services as well. Now see, this is another second type of QoS model, guys, if we are talking about. So the second one we have is your differentiated services. Now, whenever we are talking about this differentiated service model, guys, like, we can say this is also known as DevServ, or we can say that there are some points to add on this differentiated services. So like we can say the network identifies here. The network identifies classes that requires special QoS treatments, we can say. Special QoS treatments. Now, what does this mean? So we can say that, like, it is going to allow end devices and host devices to classify the packets. Allows end devices, or you can say the host devices, to classify the packet. Now, what kind to how it is going to classify the packets? Like, that can be treated into different categories, or like, classify the packets into different categories. Or what else we can say about this is like, some TCs are also used here, which is considered as your traffic classes. So according to this, it is going to identify its own traffic, like what kind of traffic it is. And like it is going to classify the packets. Either it's your, like, they need to be differentiated on the terms of traffic classes, or like over the categories, what kind of packet it is. Then we have something like it is used to design, design to address limitation of end serve models, but there is no need of RSVP flow state to maintain here, but which makes it highly scalable. So we can add this point like no RSVP flow state to maintain on every single node. because it is not going to, maintain any kind of RSVP flow. It's not like end serve model. So it will not maintain any, any kind of, we can say any kind of flow. It will not maintain. Why? Because it is going to make it, which makes it more scalable. This is, we can say, like if anybody is going to ask you what makes the differentiated services most more scalable as in comparison with, we can say, like uh, like the different services. So we can say that this model, like it's not going to use any RSVP protocols for maintaining the flows. So we can say that it is simply going to give you more scalability if it is not going to use RSVP flows for every single node and every other device. So this is what we can say. And like, here in this differentiated services, we can add like quality of service characteristics such as bandwidth and delay are managed by router to router on basis of the policies like that are defined independently on each device inside the network. So we cannot consider an end-to-end QoS solution because end-to-end QoS guarantees cannot be enforced here. So it simply divides the IP traffic into classes, and we can say that it also marks it with some based on business requirements, so that each of the class can be assigned to different level of services here. So as per like there are some descriptors which I will explain you, like where we are going to define what kind of traffic it is and which values will be used here. So I'll give you some explanation related to the OSI model as well. So there we will see. And what else we can write here, that many types of services can be chosen with diffserv, can be chosen with diffserv. Diffserv is nothing but differentiated services, guys. It's like short abbreviation. So we can say, like, for example, IP phone voice traffic is very sensitive to latency and jitter. So it should always be given the first priority and like the preferential treatment over all the application traffic. Or on the other hand, we can say like email, like a great deal of delay, which could be given some best effort in non-business, some, such as YouTube can be like, can either be having heavily rate of, like it can use a lot of bandwidth, or we can say like, some rate which is limited or blocked entirely. So that depends on the configurations, like what kind of configurations you have configured in your quality of service. So here also we have some advantages and disadvantages of differentiated services. So if we are talking about the advantages versus disadvantages, so here we have, like we can say, the first is like it's highly scalable. This is one of the advantages, that it can be used for very large enterprise networks. So it's a very high scalable QoS mechanism, we can say, and it's very easy to configure. It's not as much complicated as per your, we can say, as per the comparison with the integrated services. And here we have some, complex traffic classification as well, because I already told you that it is going to classify the data, or like, classify the data packets into as per like, categories or different classes as well. So this is how, like, we are going to discuss this type of models we have completed. Like there are two types of models. Then we have some several, terminologies here whenever we are talking about this QoS model. So we can just, let me write the name of all the terminologies here. So just let me writing terminologies. So if you will see like what kind of terminologies I'm talking about here, the first we have is your classification. So classification is there. The second we have is your marking. And after marking, we have queuing. After queuing, we have like some policing, and policing is there. The fifth we have is shaping. So these are, guys, some kind of class, QoS terminologies throughout the, like, over the entire concept of quality of services. We are going to see all these types of classifications, like where we are going to use which and how exactly we are going to use which. So what is the need of classification? Why classification is required? Why marking is required? So we'll try to understand all these terminologies now. So let's try to understand with the classification first, guys, or else just let me paste the note. Yeah. So we'll try to understand classification, marking, and everything related to this part. So we'll start with classification first. Like, what is classification? So whenever we are talking about this classification part, guys, so classification is something we can say that the different type of traffic require different traffic. requirement, like we can say different type of traffic requires requires different treatment, we can say. So depending upon the type of traffic, the requirement will be there. Like for example, we can say that, just to understand example, I will write here. So we can write one example, like if internet downloading requires burst data, internet downloading requires burst data, or whereas we are talking like voice traffic, if we are talking about like voice traffic needs continuous steady bandwidth. So these are some examples, like different type of data is going to require different type of treatment. So, here we have some traffic descriptors to use for the classifications in the classification, guys. So just let me write the heading: traffic descriptors, or we can say like used for classification, like how the data will be classified, used for classification. So here we are going to see that we have some layers, like, there is first we have internal, which is basically a part of your QoS only. So we are going to say like here we have some QoS groups only, which is internally, and that is something like locally significant on the router. Then we have the layer one. So layer one, we can say that it is going to have some physical interfaces. So we can say physical interfaces are the part of layer one, or you can say sub interfaces are also a part of your layer one, guys. Like, or we can say the port is also a part of your layer one, like whatever the port you are using. Coming to the next layer, which is your layer two, you are already familiar with layer two, which is your data link layer. So it is going to use the MAC address, right? So MAC address will be there. And apart from that, it is also going to use 802.1QP, right? It is also going to use this. And also we are going to consider one CoS here. This CoS stands for class of services. So this is one part here over the layer two, and like it is going to use CoS bits, we can say class of services bit. Then we have is layer three. So layer three, like specifically if we are defining, so layer three, it is going to use some source and destination IP. So that is the mandatory part, source destination IP. Then we have some DSCP values here. So it's a new method. And there was one more method which was used in the layer 3, which was also known as IPP, which is going to use some TOS bits. So we are not going to talk about that IPP model. Then we have layer 4, which is like transport layer. So you already know here we are going to identify either TCP or UDP, like what kind of packet. Then after layer 4, we'll directly talk about the layer 7 because we have application presentation session and all that. So we'll simply signify one application, which is also consider as NBAR2. Now NBAR means like we have network based application recognition. Network based application recognition. So whenever we are talking about this NBAR2, guys, like, for example, for enterprise networks, the commonly used traffic descriptors are used for the classifications, like, they are like for the enterprise I'm talking. So mostly and widely used is your layer 2, layer 3, and layer 4, and your layer 7. So these are something which are most commonly used traffic descriptors for your, enterprise networks. So like these are already listed here, like which is going to use which term and which is going to use which value specifically. But see guys, like if you will study as per the ENCODE syllabus about layer 7 NBAR, so you will find that NBAR is something, it is something a kind of, deep packet inspection for engine that can classify and identify a wide variety of protocols as like application layer using layer 3 to layer 7 data. Right. So it can, also recognize more than 1000 applications. Monthly protocols packs are provided and recognition of new and emerging applications are also there without requiring iOS upgrade also. So it is also having some modes like we'll not discuss the modes, but in this NBR you have some protocol discovery and modular QoS CLI. So these are some modes in your, we can say in the layer 7 NBAR2. So as of now, like this is enough for your like terminologies about the classification and how the data will be classified according to that. So this is what we have already discussed. Now we'll come to the marking, which is your second type of terminology. So we'll write marking here on the second page. Now what is this marking? Marking means like it colors a packet by changing the field. Colors a packet by changing the field within like the packet or the header of the frame, within the packet or header of the frame, depending upon what kind of like packet we are having. So to provide like customization kind of treatment with minimal impact to the network performance, we have some three methods here. Like classification is first prior part, like you need to classify. Then after classification, marking is done, which we have already discussed, like colors. It gives the colors to the packet by changing the field of packet or the header of the frame. And lastly, we have some treatment. So we can say about this, guys, marking that for enterprise networks, the commonly used traffic descriptors for making the traffic, including like, for marking the traffic, sorry, that it's going to include the layer 2 and layer 3 descriptors here widely. Like let's mention here also layer 2 and layer 3 descriptors will be there. So this is what basically marking refers to. And like there are various methods of marking the data, guys, according to like all the layers. We can say like if you are marking the data with the layer 2, let's say if you are marking the data with layer 2, so it will be marked as QoS bits, class of service bits. If you are marking the data with, we can say with a layer 3, so in the layer 3, like the data will be marked in the TOS bits, or we can say it can be used in two methods. We have some like IPP, which was like an old method, which we will not discuss about this IPP method. And we have another which is like a DSCP, which I already mentioned. What is DSCP? So just DSCP is nothing but it is differentiated services code points, differentiated service code point. So these are some, like there are various DSCP values. Accordingly, we are going to decide. So like, differentiated services code points are there to define on the layer 3. And this IPP was also like, IP precedence is the full form of IPP. So it's not used in today's organizations, but like you must be aware about like what kind of marking it is going to do with the layer 2 or with the layer 3. So this is what your classification and marking is. And apart from that, like whenever we are going to talk more in detail over there, so we can say like there are some shapings and policies. So if we are defining the shaping and policies, so like while defining the shaping and policies, we can say that, it is going to like by default, the interfaces are always going to transmit at the light speed, or we can say that shaping allows you to set transmission speed, set the transmission speed of of the network traffic. So this can be one factor. And apart from that, queuing and everything will be beyond. Queuing and everything beyond. But whenever we are talking about the policing, so what is this policing? So we can say policing also allows you the same, allows you to set the transmission speed again, set the transmission speed of the network, like as we have already known, but like it is also going to set the speed of the network traffic. But here, like it is going to drop everything and beyond, drop everything and beyond. So that depends on the kind of policy which you have configured over there. As well as like, there are some congestion management and avoidance kind of scenarios. Like these are some tools which are used for managing excessive traffic during the periods of congestions. Or like there are some of them which are used for congestion management, like whereas various algorithms are there accordingly. Like there are a few five algorithms like first in first out, if FI, FO, FIFO is also known as, like your some latency queuing algorithm we can say, or like custom queuing is there, priority queuing is there, weighted fair queuing is there, round robin is there. So these are some types of your algorithms which are used, and like these algorithms we're not going to discuss more in detail, but yes, if you want to discuss, you can go through with like the official documentation of quality of service. There you will find like some like kind of scenarios where we are going to see this kind of things. So as of now, we have discussed the types of QoS models. We have discussed the like you know the types of models, classification, marking policies as per like the parts of your QoS. Now we are going to see One more thing, which is like your one lab scenario of quality of service, like how exactly this quality of service labs we are going to perform. So we can say now that just let me share my screen for the packet tracer, guys. So we'll see one quick lab scenario as well. So let's get started. So as of now, like what I have done here is got some queries, I guess, on the chat box. All right, I'll check it out. And like, yes, Kumar Shankar, I'll definitely answer your queries. Let's quickly perform some lab scenarios as of now. So let me share my packet tracer screen. So I have taken two routers here. Like apart from that, I'm not going to like do a lot of highly configuration complex, like not more complex lab, but we will simply see some quick introduction to how the QoS is being configured. So as of now, as you can see, like I have taken two routers and all the IP configurations are already there on the devices. So we can see and verify this is your R1 show IP interface brief. So you can see like there is one IP over the gig00 interface, which is 10.0.0.1, and we have the loopback IP also 1.1. And here also we can check on the router 2 configurations, enable show IP interface brief. So we have gig00, which is identified by .2, and this is 2.1. So we'll advertise some EIGRP routes between the devices, configure terminal, router EIGRP 100. Let's say no auto summary. Network, I'm going to advertise 10.0.0.0, and again we have network 192.168.2.0. So these are some configurations we have configured. We'll go on the router 1. We'll do the same here on the router 1 to see the configurations. Configure router EIGRP 100 and network. We have no auto summary first. We have to define the network 10.0.0.0. And dual agencies form, we will write another loopback 168.1.0. So we have advertised the routes here. Now see guys, like what we are going to do in this kind of scenario, like while doing the lab. So I'm just simply going to show you one mapping of HTTP protocol, like how it is going to be done. So over the router 1, we'll go into configure terminal and we are going to write class map. Class map, like which class map you are going to define. See, you need to write the keyword name, like what is the class map. So let's say we are going to define some HTTP class map here, like we are going to classify the HTTP. Now we are going to match it with the protocol, like match protocol. If you will run the command and you can see all the list of protocols will be there. So what kind of protocols we are going to use here? Like we are going to match it with the HTTP traffic. So we will write HTTP after the command match protocol HTTP. So see HTTP if I'm going to write. So once I have written the HTTP done, I'm going to exit. I have done the classification. Now I need to create one more access list here, guys. Now why I'm creating some access list? Because I am allowing the protocol numbers here. So access list I am going to create, let's say extended, and I'm giving the list access list name as voice here. Now we will permit the traffic. So let's say permit UDP traffic we are going to allow, permit UDP any, and like then we will be having the range of the protocols. So we can define any range, like we can say 16384, let's say. So this is the range, or you can also check the range here also. You can see from 0 to 65,535 is the total number of range. So we can take any specific range, like as of now, I'm going to take 163842. So let's try to take it till 3267. 32676. So this is the range which we have specified. And then if you will put question mark here, so you can see like the command is entered. Like now we are going to run this command. So once we have executed the range here, now what we are going to do, we can verify do exit do show IP access list. So you can see here we have allowed the UDP traffic for all these number of protocols inside our traffic. So as we have configured the ACL list here, so why we have configured, because I want to give some VoIP packets with UDP ports in the destination also. So we can write something like, now we need to define one more class here. So we can write class map, and like here we are going to define it as voice. Let's say CM, like any keyword you can use, or like then we will match the protocol. So we will write match access group voice. So why I'm matching it with the voice, guys, because let's say voice. Okay, not voice. Just let me check. Yes, we need to write name here and the name for the access group which we have configured. So for the voice kind of traffic, I have allowed all the UDP ports. So now I am going to write here name and voice. So voice I have written here, done. Exit, we have done the configuration here. Or also you can verify IMAP traffic and kind of scenarios with that particular, kind of scenarios if you are going to run that part. Now again, if you will verify, show running config. So you will see in the running configurations, I will show you what are the classifications and marking we have done over the devices. So you can see I have classified some HTTP traffic and I have also classified some voice traffic over the devices. So now as we have classified the traffic over the devices, so now what we need to do is like once we have done this part, so we will now go on the interfaces, like not on the interfaces, sorry, we will define the precedence and like layer 3 information on the devices. So we'll go in the configuration terminal and we will write policy map. And like policy map, let's say what we can use, we have to give any name to our policy which we are defining. So let's say I'm going as CCIE is my policy name here. Then which class I have to define, let's say HTTP I have to define. HTTP, then you will define set class map HTTP not configured. Policy map we have configured, and what else we need to go with? Like, okay, yes, I need to set some IP precedence here. Okay, class. So class HTTP I need to go. Why it is showing class map HTTP not configured? Just let me go through with the configurations again. There is some error which we have done in this part after applying the policies. So we will see policy map. We have covered the name of CCIE and the class we have already configured. Let's try to set some DSP values if it is allowing us to. So just let's exit and let's try again once. So we can say that, let me check running configurations first, show running config. Okay, mapping has been done here. All right, so we can do one more thing, like I'll just leave that part and we can just, like cover it up in more detail. So like just going over the interfaces and giving the specific details because I'm not going to run all that particular part and configurational. So you'll simply go over the devices and all right, just let me check HTTP or HTTP. Like we will simply like verify the output first and then we will go with that type of error also, guys. So we'll write configure terminal we have already written. Then we will go in the interface gig00, which is your outbound interface. So now over this interface, we need to define the service policy. So we will write service policy. And if you will put question mark, there are two options, guys. See input and output also there. So you are simply going to write the command keyword output because we are defining for the out traffic and then you will put question mark. So it is asking you for the word. So now what word you are going to write here, like you have classified the class while doing the service policy was the CCIE. So now you have defined and you are going to write end. And now if you will verify show running config. So here you can now see that, okay, class maps are already there for HTTP and we will verify show policy map we are going to see. So policy map we have configured as CCIE, but we have just skipped one part, so which we are going to cover now, which was like, while defining the HTTP traffic. So like what we need to configure is like we will go with some ICMP or with the HTTP traffic and we will define the class HTTP. So let's say we have policy map, which was CCIE, and after defining the policy map, we will define class as HTTP. I guess which kind of error I have done. Just let me check it out, guys. Okay, let's try HTTP. Yes, I guess, yes, guys, see from the chat box, I got the error also that I have defined the wrong keyword over there. So now it is accepting this HTTP. So this is what you need to make sure, like once you have defined this part, then you need to set IP DSCP value. So DSCP values, see guys, I told you there are various DSCP values while we were discussing the lab scenario. So here we are going to use the AF part here. So set DSCP AF. And once we are going to set the DSCP, so after setting the DSCP AF, we have done exit. And also we have applied the policies. Now we'll run show policy map. Set IP DSCP AF. All right, configure terminal. We will define the policy map again. Set IP DSCP EF. Set. All right, we need to verify the command class HTTP. Set IP precedence if it is asking. Set IP DSCP and let's verify DSCP as EF. DSCP value already we have executed and we'll try to see some IP precedence also it's not supporting. If it is going to be, yeah, this command is not supported in the packet tracer guys. So you can also verify this command in the packet tracer like set IP precedence and like you need to select one more like value after the precedence like depending upon the kind of flow which you are defining. So this is how we are going to configure the quality of services. That was not a like good lab, but guys, see the thing which we have discussed here was just like I have not completed the entire lab, but as of the discussion, what we have done in this lab is like I have just given you some quick introduction, like how exactly we are going to perform the classifications and all that part. So here you can verify that to show IP. Show running config. So how you will be defining the classifications and mapping over the devices. So here we have executed this all traffic and like HTTP traffic and VoIP traffic. So like we'll also upload one more recording over like, entire QoS lab specifically that how exactly we are going to cover up the all the policies mapping, marking and shaping everything because in packet tracer we do have some limitations, but over the GNS or in even setups we can use this part. So this is like all the part from my side in quality of services guys, and maybe if you have guys any queries in this part, so now just feel free to let me know your queries. See, like there is one question in the chat box. I can see that how does the ISP set the bandwidths for C using QoS? So like we can say like in that case, it enables the bandwidth management by the application protocols, like according to the bandwidth utilization. So there are some, various we can say there is some traffic prioritizing. So like any public access channel can be used or any VLANs or ports which are using. So like depending upon the stringy signals of the bandwidth used per the subscription plans and that can be prioritized, that could be prioritized the traffic within the bandwidth. So that can protect high applications or like various several uses are there according to that. So this could be the answer to that question, guys. So basically we can say like if you are asking okay, what's the benefit of QoS over ACL Priyank? So like whenever we are using ACL kind of scenarios, so like see QoS can help you to reduce the network congestion by dropping and throttling the some kind of packets during the peak utilization, or like depending upon the ACL. So quality of service also allows you to, classify the network traffic policies and like it is going to give you some congestion avoidance. So you can, configure the QoS on the physical ports are also over the SVIs and like marking it with the access list. We can say that we have specifically allowed the traffic. Like for example, if we are allowing any UDP traffic for voice, so you know that voice is basically like little sensitive for your, we can say like latency and jitter. So there you can execute this ACL for some specification of the traffic also. This can be one of the advantage of QoS over ACL. So that's all from my side, guys, in this QoS webinar. And I will also share one ebook and like one kind of notes to go through with the entire statements. And also like we will add one lab guide by the end of your like when the recording will be uploaded. So like you can go through with the lab guide and the GNS or even G. So that would be a perfect lab combination. So that's all from my side, guys. Thank you very much for joining.